All right, boys and girls, welcome back to the drive-thru. Sponsored by the deli. Hungry? Stop by the deli. Get yourself some delicious baked wheat thins. Garden Ranch. All right, so we are on number 29 from 11-2. The directions state the following. Find the open interval or intervals on which the curve by the given vector-valued function is smooth. All right, the function for our vector is r of theta equals 2 cosine cubed theta I plus 3 sine cubed theta j. Okay? Now, one thing that I always kind of hated about that notation is it sets you up to screw up the chain rule. So I'm going to write that as 2 cosine of theta cubed I plus 3 sine of theta cubed j. That's going to remind me that I need to use the chain rule. Okay, so in order to find the interval in which this curve is smooth, I've got to find all the places where the derivative is equal to 0. So let's find the derivative. Well, that's going to be 6 times what's inside, cosine of theta, squared times the derivative of what's inside, which is negative sine theta, plus 9 times what's inside to squared times the derivative of what's inside, which is cosine theta. Here's our I and our j. Okay, so we can clean that up by saying r prime of theta is negative 6 cosine squared theta sine theta I plus 9 sine squared theta cosine theta j. Well, we want to know what values for theta makes this thing a 0 vector, and at those places the curve will not be smooth. Okay, well, if we set it equal to 0, we should just factor a negative 3 cosine theta sine theta, they all have that, times, here we're left with a positive 2 cosine theta, and here we're left with a negative 3 sine theta. Okay, see how we factored that out? Now, there's a reason that this is a 2 and this is a 3. Since those are different coefficients, this will never equal 0 here, okay? Because cosine of theta and sine of theta do indeed equal each other when theta equals radical 2 over 2. Sorry, when theta equals pi over 4. But since we have a coefficient of a 2 and a 3, this thing right here will never equal 0 for a time theta. However, anytime cosine theta or sine theta equals 0, the factored portion of the function will indeed produce 0. So cosine of theta equals 0 at, let's see, pi over 2 and 3 pi over 2 and 5 pi over 2. So n pi over 2, right? And sine of theta equals 0 at n pi. Okay, so this thing will be smooth on the interval from n pi to n pi over 2, where n is an integer. So it looks like it's going to be smooth every 90 degrees, if you can think about it that way. And I've pulled up my handy-dandy grapher. And this is what the graph of that function looks like. I'll scroll down so you guys can see how I type that in. You can see I just went to a parametric graphing function and typed in 2 times cosine of t quantity cubed for our x value, 3 times sine of t quantity cubed for our y value. You'll see we've got this pretty little star here, and right here you got a node or a cusp, and it's not smooth there, so we are verified by our grapher that this indeed is the values. Boom!